right, good morning, good morning, good morning. Hope you're having a good morning. This will probably be a fairly short one because it's cold today. We haven't hit 50 yet, around 46, 48, something like that. All right, well, I hope you have, I have a warm beverage here, so maybe hold it a little bit close to me. But I hope you're having something to get your morning started. I want to have my sip of coffee right now. Mm. Luna probably won't join us because we have somebody, uh, sounds like getting a house, the shingles replaced on the house, so that she'll stay inside because she doesn't like that noise. It's unusual for her, and she's really kind of good. Thunderstorms and stuff like that. She'll do a little bark when she first hears them, but then she kind of huddles next to me, and she's pretty good for a dog. I mean, most of the dogs I've had much more reaction to thunderstorms than she did. But she's also she likes things to be the way they are. She's got that little bit of a, I want the same rhythm routine. She gets, she likes that. So this is unusual sound, so she won't be out here very much if she at all. Um, I want to keep this short, but I want to talk a little bit about fusion power. Um, you know, we had a announcement of an experiment where they actually got um, fusion power to work correctly, and they got more energy out than they put into it. For and that's big breakthrough. Not a huge amount of power, but it was a demonstration. Now we have to scale it up, and work on making it bigger and delivering the energy and stuff like that. There's a lot of work ahead, but we're probably looking at some significant power improvements as far as a reusable source that's clean. We're very worried about the carbon output, but very clean. Uh, Worked for a long time, hopefully, but it's still probably at least 2 or 3 decades out before it's actually making a real dent in our electric grid. But anyways, my primary purpose in this, because I'm not a nuclear engineer, although I did start my college career as a physicist, but I stopped. I went through a year and a half, and then I quit and went into business, and then I quit that and went into engineering. The reason I left physics was because I looked at the career opportunities in physics, and it marshaled itself around very small groups of people. And I really like working with a team. So I left that and went to business because we're always working with a big team. But then business, my skill set, I could do business and did really well at business, but I felt like I was missing something. I liked the little technical parts. So I went into engineering. So I became an electrical engineer. And after electrical engineering, I went into uh, computer science 20 years later. So that's it. Physics, business, engineering. And a long time later, computer science. And that's where I'm at right now. I program a lot. Um, Love programming too. I enjoy programming. Well, I found my niche. Um, However, back to nuclear uh, uh, Fusion. Fusion, and I'm not going to tell you everything. You can read up on what the difference between fusion and fission is. But, the basics is it's merging things together creates energy, pulling things apart, which is what we're doing right now, creates energy. And that's what they did was they took two hydrogen and pushed them together. I think they produce helium, or at least a heavy hydrogen. I don't know. I haven't looked at their research, but it is a big deal. And I want to do the caveat of there's a lot of stuff that's happened over the years. When I was 14 years old, remember I said I started college as a physicist. When I was 14 years old, I was very interested in physics. I was reading books about physics, Isaac Asimov's three-book series on physics. I read that, and I loved it. And I was living in Memphis, Tennessee, and on the other side of Tennessee was where a lot of the nuclear research for the nuclear uh, programs and during World War II were done, and some of the bomb research was done there too. And so I was like, looked it up, and they had places you could go see at Oak Ridge, Tennessee. And so my parents, I was the only child, so usually they would do almost anything I wanted to do. So I said I wanted to go see the these places. So we got there, and it was fascinating, all the stuff about nuclear energy. I think we may be we may have been a lot better off. That it's loud out here, sweetie. I know. I know. You're worried about me. It's okay. I'm going to come in. We're going to keep this short. We'll keep it short and then we'll go inside. Yes, it's okay. I know. You're worried about me. You're worried about me being out here, all that noise. So, uh, got to Oak Ridge and I'm like looking at all this cool stuff. And I'm like I was about to say, I, I think one of the travesties of the uh, our time here is we didn't use nuclear power more intelligently as far as how much it could have reduced the uh, greenhouse gases and a lot of other things. It could have made it much, much better for us. But that's neither here nor there. That just happened. There's a lot of uh, fear and lack of knowledge that caused a lot of those things. But um, what I wanted to say was even then, I remember a display called Tokamak, toroidal magnetic container, something like that. The Tokamak was, I went in there and the display was amazing. You actually went inside this chamber and they would talk about how they would have this plasma and you would move it around and get it up to a temperature and then you would hit it with a laser and it would create this extra energy. And even back then, they thought we're right on the edge of making fusion energy. Yeah, that was a long time ago. Never happened. Well, I shouldn't say never. It has now. It's been a long time. So I'm excited that they did this. It shows it's possible. It's a big deal when they show something's possible, even if it's a very small amount of energy. I think they said that you could warm up like around 9 kettles of water with it, but that's okay. There's scaling, there's lots of issues with doing it, but it will be amazing when we get it done. And yeah, 20, 30 years, 2050, might not be here anymore. Don't know. Let's see. I'll be 30 years from now, I'll be 90. That's about the time most of my family departs. So I might be here. At least I'll get to see it. I guess, that's part of the fun is just seeing things change and dreaming of the future. Sometimes when you actually get it done, it's a little bit like an anticlimactic. Oh, okay. But it's kind of exciting when you start and you're working on it. Anyway, it's good news. It's great news. We needed some great news. There's so much things that are not good. So here, a toast to all those people working on that project, and thank you for the good news to end our 2022 year. Thank you very much. And I hope you guys have a wonderful experience with your looking up the fission. I'm sorry, fusion. See, I'm used to saying fission because that's what we usually do. I gotta start saying fusion. Fusion. Toast, you guys. We'll talk to you later.